Welcome to lesson 49. Today we're going to focus on situations where the x that we're solving for, the variable that we want to solve for, is inside of a radical. It's inside of a radical. We call these radical equations because x is inside of a radical. So the first question, of course, is how do you get it out of the radical? Well, often it's not too hard to do, really. You just think in terms of, hey, that's a cube root. How do you get rid of a cube root? You get rid of a cube root if you raise it to the 3 power. Of course, you have to do the same on both sides. Do the same to both sides, maybe I should say. So you cube the cube root, and the cube root goes away, and the left side is just a 2x plus 3. That was nice. Okay, over here, what do I got? Negative 4. When you raise it to the 3 power, you get negative 64, right? 4 times 4 times 4 again. 64, negative. Cool. Now, that did a lot for us, right? All we got to do now is, maybe I'll do it in different colors. We do the old subtract 3 on both sides. So you get a negative 67. And then you do the old divide both sides by 2. And you get a negative 67 halves. And there is your answer. There she blows. That's a 67, by the way. I kind of messed it up there, didn't I? Negative 67 halves. That's your answer. That's your answer. That's your answer. Okay. Now, if you have a square root instead, here's x. It's inside of, not a cube root, but a square root. Well, guess what? What are we going to do to both sides? Can you tell me? To undo a square root, we're going to need to square both sides. So I'll just say that I'm squaring both sides. I don't want to clutter my problem up too much. I don't like clutter. So 2x plus 3, when you square it, you get 2x plus 3. Maybe I'll put it this way, SBS for square both sides. It takes off the radical on this side, and then the negative 4, when you square it, becomes a 16. And that's like, oh man, this is like so much fun. Let's just subtract 3 from both sides again. So negative 16 minus 3 is a minus 19. Let's divide both sides by 2 again. And here we go, negative 19 halves. Are you having fun yet? Okay, wait, before you get too happy. How's that answer look? Does that look like it works? Does that work? We want a solution to this equation, right? We want it to work in the original equation. Let's check. Check. So I have a radical 2 times, and then we're saying that x is a negative 19 halves. Okay, fine. And then I still get this plus 3 inside the radical. Does that equal negative 4? Question mark. I switch colors again. Keep track of my flow here. Well, when you multiply 2 times a negative 19 over 2, the 2's basically cancel. So you got that would be a negative 19 plus a 3. And you can see we're running into trouble already here. This is, let's see, that would be a negative 16, right? And actually, what is this? When you take radical negative 16, you get, first of all, positive, and you get 4i. That's not this. It didn't work. That does not work. We call this an extraneous solution. It does not work. We have to throw it away. Throw it out. Never hesitate to throw it out if it doesn't work. It doesn't work. Throw it out. Now, if we were alert, we might have been able to see this right away, because remember, we've said this before, that the radical symbol indicates the principal or positive root. So this has to come out positive. When you take a radical something, it has to come out positive. So what's this negative 4 doing here? It cannot possibly equal negative 4. It can't, because that's not what the symbol means. The symbol means, give me the principal root, give me the positive root. We ain't got no positive root. We ain't got no solution. No solution. There is no solution to this thing. We thought we found one, but it didn't work in the original, so therefore we throw it out. This is a major deal. Major deal when solving radical equations. You must check your solutions. Must. Usually we say, oh, check your solutions. It's nice. You can know you're right. But now, in this case, you must verify any solutions you find, because sometimes you'll have to throw it out. Some could be extraneous. And you want to put like a little horror face here, you know, oh no, extraneous. And then you'll have to throw it out. Okay, so keep that in mind. Again, this one we could have spotted right away if we thought about, well, that symbol means the principal or positive root, so it can't be negative because -4 is not a positive root, so that couldn't possibly have a solution. Okay, sometimes it'll be obvious, but not always. So you must make it a habit. You must verify your solutions to these things. Okay, and that's the first big point I needed to make. And I made it. Okay, let's see if there's any other points we need to make when we're solving these radical equations. Well, there's the basic idea, of course, which is to simply, you want to get rid of a square root, you square it. Here, I want to get rid of square root, so I'm going to square it. Square both sides. X is inside of a radical. We don't like that, so we're going to square both sides. Now, when I square the left side, all it does is remove the radical. See, I like that. Now, be careful over here. What does it mean to square the right side? To square the right side means to make the right side times itself, like this. It's a FOIL, in other words. So that's another thing to keep in mind. I see this mistake a lot. People say, well, I'll square the x and I'll square the 7. And it's like, no, it doesn't work that way. You have to square the side. You multiply the side against itself. You do this FOIL thing. So as long as you're careful there, everything should be fine, I think. So I got an x minus 1. Start a FOILing. X squared minus 7x. Minus 7x again. You see why FOILing is so important here. And then plus 49. Okay, cool. Let's get rid of that garbage. So, looks like we got a quadratic equation shaping up, right? Because I see x squared. This is going to be a quadratic equation. So let me first, let's see now here. First thing I'm going to do is I'm going to combine the minus 7x and the minus 7x to give me a minus 14x, right? So combine those two things first. And now, when you have a quadratic equation, you'd like it to equal 0 before you can solve it. So I'm going to subtract x on both sides, and I'm going to add 1 on both sides, which will make the left side 0. Did you follow that action? I subtracted the x on both sides. I added a 1 on both sides. That makes this side a 0. Okay. And maybe now I'll just kind of go like this. X squared. Oh, right over here. X squared. Okay, so minus 14x minus another one. That's a minus 15x. Plus 49 plus a 1. So that's plus a 50. And this stuff equates to 0. A nice quadratic equation in standard form. I'm even going to write that down. That's a nice phrase. Voilà, une quadratic equation. To say it in French, equation. I'm only kidding. Quadratic equation in standard form. Now you could grab out your quadratic formula if you're kind of reflexive like that, like, oh, quadratic formula, I love that thing, let me use it again. Or sometimes it's a lot faster if you just do a spot check and say, I wonder if I could just factor the darn thing. Two numbers that multiply to 50 and add to 15. Does a 5 and 10 come to mind? 5 times 10 is 50, and if you add those, you get 15. Now, actually, I want negative 15, so it should factor like this. It should factor like this. And so, look, you got two solutions. X equals 5, x equals 10. Now, I said two solutions, but what I should have said is that these are candidate solutions. You must check. You must verify. So let's get back into the green mode. Okay, so check in original equation. You have to check both of these. So the original equation's up here. So radical, let's see, if I put my x equals 5 in, that would look like this. And on the right side, I'd have a 5 minus 7. So the left side is a 4. Square root of 4 is 2. The right side is, well, actually 5 minus 7 is negative 2. That does not work. Does not work. 5 does not work. Now, usually one of them will work, at least one of them will work, but you can't guarantee it. You have to check. So let's just see if this is going to check. So now I'm putting the 10 in. So where I see the x, I put a 10 in, minus 1 equals a 10 minus 7. Does this work? That's a 7. 10 minus 1 is 9. Square root of 9 is 3. 10 minus 7 is 3. That works. And so our solution is, Maybe I'll put it in a nice purplish. X equals 10 only. Okay. So we've done a page of these things. What have we learned already? Well, let me scroll back up. We have learned already that A, the way you get rid of a radical is to use an exponent. You want to get rid of a cube root radical, you cube it. You want to get rid of a square root radical, you square it. Make sure you do the same to both sides, and sides will often mean foiling, so there's that. Make sure you always check your solutions. That's this big thing here. Make sure you always check your solutions. So, yeah, we've made some pretty good points here. Anything else we need to know? I think I got 2 more examples. Ooh, 3 more examples. Ooh. That last one's a quick one. So anyway, at least 3 big ones. Let's see. What do we got here? Well, it's a good thing we learned how to interpret a fraction exponent. Remember, that's just a square root radical. The 1/2 power basically just means that I've got 12 minus 2x inside of a radical. Now, plus 2 equals x. Now, here's another thing I'm going to say. So let me get out my purplish color. Yeah. So another thing I'm going to say is, and this is a huge tip. It's more than a tip. It's practically a commandment, because if you don't do this, you're going to make a mess for yourself. But tip. First, isolate the radical. Before you go squaring both sides, isolate the radical. Now I'll show you real quick. Don't write this down because it's a mess. See, I can erase. That's what's nice here. Watch, I erased. Isn't that cool? So anyway, if I were to actually square the left side, I would have to take this times itself, and hopefully that's looking a little weird already, right? You want to multiply this times this, and then this times this, and then this times this, and then this times this. Let's just not. First, isolate the radical, i.e. minus 2 on both sides. BS is both sides. Subtract 2 on both sides. So I got my radical, 12 minus 2x here. After I subtract 2 on both sides, I'm looking at this. And from here, we're ready to go. You can square both sides. Make sure you do the foiling thing. And so on. You might end up with the quadratic equation again. You can try to factor it. You should try that yourself, right? Because that's how you learn things, is by just trying to yank stuff out of your own mind. You don't just watch. You can't just watch math and learn it. You have to yank it out of your own mind. So try it yourself. Try to square both sides and all that stuff. Pause. Come back. Okay, so I'm going to square both sides. Yes, I really am. So the left side becomes just 12 minus 2x. The right side becomes make sure you FOIL. So you got an x squared minus a 2x minus a 2x again, and then plus a 4, right? So make sure you FOILed that out to get this. I do indeed see a quadratic equation shaping up. So if I do the old subtract 12 and add 2x on both sides, subtract 12 and add 2x on both sides, I'm going to have an x squared. I'm going to have a minus 4 plus 2, a minus 2x, plus 4 minus 2x, a minus 8 equals 0. Quadratic formula, schmadratic schmormula. I think we can just factor this. 2 numbers that multiply to 8 and subtract to 2. How about 2 times 4? 2 times 4 is 8, and if you subtract, you get 2. So let's see, how would I have to arrange my signs? I would have to try to add up to a negative 2, right? So I'm going to have to do it this way. That'll work. If you FOIL that out, it works. So coming over to here now, we have 2 candidate solutions. Remember, we're not done yet. These are just candidate solutions of x equals either negative 2 or positive 4. You have to check both. So you check in the original, and I usually use green to check. So I'm using green to check. So if I were to stick a negative 2 in here, I'd have 12 minus 2 times a negative 2, like this. Plus 2 equals, does that equal to, I'm supposed to plug an x in, right? So does that equal to negative 2? No way. Because this is positive, and if I add something, it's not going to come out negative. Negative 2 does not work. How about if we try the 4? 12 minus 2 times the 4, like that. Plus 2. Does that equal x, which is 4? Question mark. Well, in here I'd have a 12 minus 8, which is 4, and the radical 4 is 2. And 2 plus 2, guess what? That really is 4. And so the solution is that x is equal to 4 and only 4. The other solution did not work. Nifty, right? Okay, now I'm going to have to ramp it up a little bit. This next example, you can tell already that it's a bit of a ramper because there's not just one radical. There's two radicals. Two radicals. Oh boy. Fasten your seatbelts. We got two radicals. Now if you scroll back up to this one, remember what I was saying here. I was saying first isolate the radical. Well, that tip is still in play, although in this case you have to first isolate a radical. you can't isolate both. First isolate one of the radicals. Doesn't matter which one, it really doesn't. First isolate one of the radicals. Or be prepared to rip out a lot of hair. I mean, it's your choice. You could try it if you want. Try squaring this side. Try foiling it against itself. You will quickly change your mind. So what I'm going to do is I'm going to add this one on both sides. So I'll leave this radical 3x plus 1 here. On the right side I'll have 2, and I'm adding this radical to it. Okay. Now comes the square both sides trick. SBS, square both sides. The left side, well, that's nice. It's all in a square root. So if I square it, it all comes out of the square root. What's a little goofy is you do have to square this side this way. You do have to foil it. You have to multiply it against itself. So this is going to be a little bit of work. So the left side is a 3x plus 1. Fine. Okay. 2 times 2 is 4. That part works. 2 times the square root of x minus 1 is 2 times the square root of x minus 1. That's what that is. Okay, now you got to do this one. That gives you another one of those things. Plus 2 times the square root of x minus 1 again. Okay, cool. Then you multiply this times this. Now when you multiply the square root of something times the square root of something, you just get that something out, right? In other words, the square roots are going to kind of cancel here, right? Because if you multiply this by itself, that's the same thing as saying I'm squaring it, right? Multiplying it by itself. And again, multiplying, if you square a square root, it just pops right out. So you just get your x minus 1 right there. So that part at least is kind of nice. Okay, so where are we now? The left side is still a 3x plus 1. At the moment, I've got a 4. Notice these are like terms. 2 thingies plus 2 thingies makes 4 thingies. So I got 4 thingies. Like that. I still get this plus x minus 1. Well, we still have a radical in our equation. But notice we only have one radical in our equation. We used to have 2. So we are making progress. So what makes these problems kind of interesting is that whenever you have 2 radicals, you're going to have to kind of isolate and square, and then you're going to have to isolate and square again. It's like a 1-2 punch. We have to start all over again. Isolate that radical. So I'm going to have this 3x plus 1 over here, and now I'm going to subtract 4 on both sides, and I'm going to subtract x on both sides, and I'm going to add 1 on both sides, and it will leave me with this. So 3x minus x is 2x. 1 minus 4 plus 1 is a minus 2. Equals 4 radical x minus 1. They just want money on the phone. We don't need to answer that one. Okay. 2x minus 2 equals 4 radical x minus 1. Okay, here we go. Oh, I can show you another tip right now. Tip. Now again, if you're going really fast, you might say, hey, why don't I just square both sides now? But before you square both sides, how many terms have we got here? We've got, that's a term, and that all counts as one term. We've got 3 terms. Notice all 3 of these terms can be divided by 2. And so that is nice because that will make your equation simpler. So that becomes just an x minus 1. And here the 2 cancels into the 4, leaves me this. Now, which would you rather play with, this or this? I mean, especially when you're getting ready to square both sides, right? I think I'd rather cancel that 2 first. So now comes the part where I square both sides. I'll hit back to blue now. Square both sides. Square both sides. So the left side, again, you're going to have to FOIL. Write it out if you have to. But you FOIL x minus 1 times x minus 1. You end up with x squared minus 2x plus 1. On the right side, what does it mean to square this? Well, if you had this and you multiplied it by itself, remember you can multiply things in any order. The 2 times the 2 is going to give you a 4. And then the root times the root is going to release that x minus 1 like this. Okay. So you basically square the 2 to get a 4, and then the square takes the square root off. 4 times x minus 1. Okay, cool. Now I'm going to have to come up here. I've got an x squared minus a 2x plus a 1 on the left side equals a 4x minus a 4, right? Just distribute over here. Looks like we do have another one of those quadratic equations popping up. X squared, if I subtract the 4x on both sides, I'll have a minus 6x. And if I add 4 on both sides, I'll have a plus 5. And now my right side is a 0. Quadratic formula, schmadratic schmormula. We can factor. By the way, every now and then you might actually really need to use the quadratic formula, so don't just forget about it. But typically, or at least more than half the time I've noticed, we can usually just factor these darn things. So 5 times 1 is 5, and 5 plus 1 is 6. So we're in good shape. Yeah, that'll work if you double check that. X squared minus a, yeah, that works. And so we've got our 2, once more, these are candidate solutions. X equals 5, x equals 1. You have to verify in the original. So back to the original. Check in original equation. So where's the original equation? There it is. So if I check the 5, square root of 3 times 5 is 15, minus 5 minus 1 is 4. Does that equal 2? That would be a root 16, which is a 4. That would be a root 4, which is a 2. And actually it worked. Cool. Now let's check the 1. If I put a 1 here, 3 times 1 is 3, plus 1 is 4. And if I put a 1 there, that's a 0. And actually that works too. That works. But they both work. How do you like that? They both work. Nifty difty. They both work. So I'll just circle both of them. Say that's the answer. That was a pretty good problem. A little longer than usual, but that's to be expected when you have these, when you have 2 radicals showing up. That's going to happen. But the process is basically the same. Is you isolate a radical first. Isolate one of them at least. Doesn't matter which one. Isolate a radical. Then you square both sides, being careful about the foiling part. You'll still have a radical in there, so you isolate that one. Square both sides again. Get your solutions, check them out, see if they work. Plus we had this nice little tip over here about the old, if you can divide everything through, do it. Make your numbers smaller. It makes your life easier. So that's about as tough as these will get, really, is when you have 2 radicals. Here's one where we have 2 radicals, and it would be a fabulous idea for you to pause the video and try that one yourself. I'm going to assume you paused the video and you tried that one yourself. Now I have no idea what the answer is, so I'm going to have to work it out. So first I'm going to subtract this on both sides in order to isolate one of these radicals. 6 minus, and again it doesn't matter which one you isolate, you get the same answer in the end. Now comes the part where we square both sides. And I think what I'll do is I'll just, instead of putting a square on it, I'll just make another copy right away so I can see the foiling action. The left side becomes just a 2x minus 1, right? The square removes the square root. Fun. Over here, okay, here we go. 6 times 6, 36. Minus 6 times root x minus 12, okay? And then another one of those, minus 6 times root x minus 12. Okay, cool. And then when you multiply this times this, minus times minus is plus, And a root something times the root same thing just basically removes the root. So you just get an x minus 12 sitting there. There we go. Looks like we have two radicals, except those are like terms. They go together. So I've got a 2x minus 1 equals a 36. Okay, those make a minus 12, right? Minus 6 somethings, minus 6 of the same thing. You've got minus 12 somethings plus x minus 12. Now I'd like to isolate this. And I think what I'll do here is I'll add this to both sides. Who cares? I'll just leave it where it is. So I'll take this 2x minus 1. Now I'll subtract 36 on both sides. Now I'll subtract x on both sides. Now I'll add 12 on both sides, and I'll leave that negative. Who cares? Who cares? So the left side is a 2x minus x is x. That's unfortunate. 2x minus x is x. Then I get a minus 1 minus 37 plus 12. Minus 37 plus 12. Minus 25, right? Wow. And on the right side, I've got a negative 12 root x minus 12. Well, this one's a little more intense than I was expecting. But it can be done. It can be done. This is the part where we say I've got my radical isolated. Let's square both sides. The left side, you FOIL it out carefully. You've got x squared minus 25x minus 25x. And then 25 times 25 is 625. On the right side, when you square the negative 12, you get a positive 144. And when you square the square root goes away. Well, it is what it is, folks. Let's just keep cranking. So I've got an x squared minus a 50x plus a 625 equals, here, 144 times x. And then this is, I want to say, 1728. 12 cubed is 1728. I just happen to know that. So anyway, okay, we've got a quadratic showing up. Let's subtract the 144x and add the 1728 on both sides. X squared minus, this will become a 194x. Wow. Plus, you know what? I wonder if I've made a mistake. 1728, 23, 53. Does that look about right to you? Well, I am just gonna double check real quick that I did this. Square root of 2x minus 1 equals 6 minus, that looks good. 2x minus 1, 36 minus 6 of those minus 6 of those is minus 12 of those plus an x minus 12. That looks good. So 2x minus 1 minus 36 minus x plus 12. Yep, that seems okay. So that's a 2x minus x is x. Minus 37 minus 27 minus 25. That's right. That's right. So x squared minus 50x plus a 625 equals a 144 times x minus 12. X squared minus 620 is 144x minus 1728. Wow. Okay, that's what we got then. Minus 194x, 1723. Wow, that's what we got. Yeesh, wanted to make sure. Okay, so we could try to factor, I suppose. Anybody feel like breaking up 2353? I suppose we could also grab out the quadratic formula. Maybe that's not such a bad idea in this case. So remember, negative b plus or minus square root b squared minus 4ac, the whole mess over 2a. I'll definitely be grabbing my calculator on this one. So a negative, and then the b is a negative 194, plus or minus square root. You take the negative 194, put it in parentheses and square it, minus 4 times a is 1 times c is, try to squeeze in a 2353 right there. And that's all over 2 times the a is 1. Okay, so that's a 194 plus or minus the square root of. Mr. Calculator, where'd you go? So I'm going to see what that number is. A 194 squared. And then minus, I got 4 times 2353. This is telling me that it's a 28 to 24 inside. Cool. All over 2. And the square root of 28 to 24 comes out even. How do you like that? 194 plus or minus, and this is the 168 all over 2. So our two solutions are, let's see now, 194 plus 168 is 8. 194 plus 168 is 362, and when I divide by 2, I end up with a 181 as one of my candidate solutions. And then the other one, 194 minus 168 equals 26, and when you divide by 2, you get a 13. Wow. Okay, so two candidate solutions, 181 and 13. You have to check them in the original. I bet you anything 181 won't work. Not in here. You take 2 times 181, you get a big number. You take the square root, it's still big, much bigger than 6, even before you added this part. 181 won't work. But what about the 13? Hopefully the 13 will work. So to have 2 times 13 is 26, minus 1 is 25. Okay, I just put the 13 right there. 26 minus 1 is 25. Okay, plus. Now if I put a 13 here and subtract 12, that's just a 1. Does that equal 6? And it does, because that's a 5, that's a 1, that's a 6. So the solution then is x equals 13 only. That one didn't work. So I used the quadratic formula in this one. By the way, when the quadratic formula gets you a nice answer like this, 13 and 181, that's telling me that we could have factored the 2353 as a 13 times 181. But we didn't. Oh well. All right, this is just a parting shot. This one's got nothing new. It's not even that complicated. It's just a little on the mysterious side, because you've got a cube root over here, you've got a square root over here, and you need to face this mystery. How am I going to deal with this? So I give you a second to think about that. Pause. Come back. Well, the answer is, pay attention to the x. The x is in here. It's the x that I care about, right? I want to get x by itself. I don't particularly care if x comes out to equal the square root of 3 or something. I don't care about that. What I want is to get x by itself. So because I need to get the x by itself, and because the x is inside of a cube root, that's telling me that the thing I got to do here is I've got to cube both sides. The left side will just become a 2x plus 1. Cool. So what do you get when you take the square root of 3 and you cube it, i.e. when you multiply it times itself 3 times? Well, when you multiply 2 of these together, you just get 3. So you've got 3 times the square root of 3. That's what that is. 3 radical 3 would be a better pronunciation. So there. Do I care that I have a 3 inside of a square root? I do not care. I don't have to square both sides. I see people do that kind of reflexively. You don't have to do that. Get x by itself. That's the name of the game. Just get x by itself. What should I do here? I know what I should do here. I should subtract 1 on both sides. Subtract 1. So the left side is a 2x. The right side is a... And custom is to put the negative 1 first, like this. I'm just going to say looks better than this. 3 radical 3 minus 1. That doesn't look as good. And it runs the danger of sometimes, hey, why does this keep happening to me? Okay, so anyway, it runs the danger of when people are writing really, really fast and they make this line because they're going in such a hurry, their pen has all this momentum going, and all of a sudden it looks like you want the 1 inside the radical. You don't want the 1 inside the radical. So just to avoid that problem, it's much nicer to put the negative 1 in front. Next, we would what? Divide by 2, right? Just divide the whole side by 2 like this. And there you go. X equals negative 1 plus 3 radical 3 all over 2. Mystery solved. Well, I hope you're digging on these quadratic equations. My computer turned off. Oh, here we go.